In this video, we'll take a look at the basic equipment required to run a 5G radio network. First, let's have a quick look at the general network layout. A 5G connected device such as a handset is referred to as user equipment or UE. UE communicate with a base station by sending and receiving radio waves. Many UEs can connect to the same base station at any one time. The base station delivers the radio signal to a location and processes the data exchanged with connected UEs. The base station is connected to the network core, which amongst other things is responsible for UE authentication. This can run on local hardware or in the cloud. The connection back to the core is called the backhaul, and while it is desirable for this to be a high bandwidth wired connection, it could also be another radio link. Note that there will likely be additional networking hardware between the base station and the network core. The core provides breakout to backbone internet connectivity and has interfaces that can connect to third-party and telephony cores. The network core can connect and control multiple base stations, providing them with user authentication and internet connectivity, as well as routing traffic between devices connected via different base stations. It also negotiates the transition of a moving UE from one base station to another. We'll now focus on a single base station and discuss the minimum hardware required to create a 5G network. This is the baseband unit, or BBU. The BBU processes the data sent and received over the base station's radio network and communicates with the network core to provide authentication and connectivity to external networks and the internet. Note that if desired, the BBU and core can run on the same physical hardware. The radio signals that will carry data over our wireless network are produced by a remote radio head. The remote radio head is connected to the BBU by high-bandwidth fibre optic cable. It takes the network data and produces a modulated RF signal with a specified frequency band and channel width. In order to be transmitted and received by devices, the generated signal must be distributed by an antenna. The antenna is connected to the radio head by RF cables. Once it's all connected together and properly configured, the network is up and running, delivering a 5G radio network. With the radio network running, we can now add user equipment. These can be mobile handsets and tablets, or consumer premises equipment to produce local networks using the 5G network for data backhaul and internet connectivity. But we're not limited to small consumer devices. 5G connectivity could be fitted to ferries and trains and other forms of transportation in order to provide widespread and consistent internet connectivity for passengers or for onboard management and safety systems. 5G offers many opportunities in rural and otherwise poorly connected communities, for example for agriculture, logistics and healthcare. Since 5G networks can be entirely software-defined, the bandwidth can be tuned to provide increased upload speed. This can be used to carry high-definition video for remote and wireless production, or even live broadcast. In fact, we can start to connect an entire Internet of Things for safety, security, monitoring, entertainment, anything that we can attach a 5G modem to.